first of all, let me say again, if you should be able to look at this and know that the center of the circle is at 2, 0, because you do the opposite of what you see there. And actually, I'll show you this. From algebra 2, you should know that the standard graphing form for a circle looks like this. X minus 8 squared, y minus 2 squared equals r squared. So the center is h comma k, which, once again, those coordinates are the opposite of what you see in the equation. And r is the square root of that. Okay? So I'm saying, from here, you know the center is at positive 2, 0, and the radius is 2, which means you're dealing with this circle here. And these points above and below basically go up 2 vertically, and just kind of try to line it up as best you can. This grid, frankly, is not, I think the grids in this aren't circles. It's supposed to be, but they're not. And so it's going to be off. As long as you get the radius 2, the center's in the right place, I'm not going to really worry about those points. I'll just tell you. Okay. Now, let's do the algebra. And one thing you should be able to do on all these is you're supposed to find the polar graph, polar equation, you mean. But I'm saying you should be able to look at the equation in both forms and make sure they're the same shape. So I'm saying I would graph it first from what they gave you, and then do the algebra and make sure that corresponds. What I had a lot of people doing, especially in the previous periods where I didn't do this algebra, is they get the circle going the wrong way, and they just write the equation from that wrong circle and get it wrong. So let's do the algebra. When you FOIL that out, the formula goes a squared minus 2ab plus b squared. So you do the middle term, you do 2 times x doubled is 4x to the middle term, plus b squared is 4, and then you have the y squared, and then you have the equals 4. And then the 4's just go away. You subtract 4 from both sides. They're gone. So you get x squared plus y squared. I'm kind of regrouping it, rearranging it. Because then that is just what? And this is minus 4r sine theta. Or maybe cosine. Depending on if you want to do it right or not. And I'm going to roll. Now, listen. I'm going to have a common factor of r. If you're solving equations, you really should factor that r out. But I'm just going to divide it away. I'm just going to discard it here because it really doesn't matter. Like I said, what I'm losing by discarding that is this equation, r equals 0. Well, that's just a point. It's a pole. And I don't really care about it, frankly, in this case. But just be careful about doing this. Generally, you should factor the r out and get 2 separate equations. And there you go. R equals 4 cosine theta is the equation of that circle. And you're done. Okay? So instead, best bet, graph based on the original equation, convert it algebraically using formulas, and then make sure that matches. All right, there's one more on this I want to go over. We need to cover a number of things today. Look at number 40. Now, if you want to graph this from the polar, kind of work on some. And by the way, you need a calculator. Go get a calculator if you don't already have one. If you do have one, go ahead and type this in. You need to figure out theta. So do the inverse tangent of 4. And go ahead and do degree mode. It's your option, but you'll have a better sense of where the angle is in degrees. I don't care. We're not graphing right now. Just on the main screen, do inverse tangent of 4. You should get 75.9 degrees. Yes? And if you draw that equation, you get a line that goes through 75 degrees, but a little bit more. Your angle is slightly, it goes through the pole at an angle of slightly more than 75 degrees from horizontal. So that's what you should see when you graph this thing. So what I'm saying, when we convert to rectangular, it should be an equation with that same line. So here, when you convert this thing to rectangular, which formula should we use? You have 4 formulas that we use for all of this. When I say all this, I'm saying we did vectors. We did the same formulas. X equals r cosine theta, y is r sine theta, tangent of theta is y over x, and then Pythagorean theorem. This way, in this case, you want tangent of theta equals y over x. That's the formula we want to use. And what we know is that tangent is 4. Tangent of theta is 4. So actually, you just replace that with 4. It feels kind of weird, maybe, but okay. You have to go now. And then you rearrange this, basically multiply x, you get y equals 4x for your equation, which would be the equation for a line with a slope of 4 going through the origin, wouldn't it? Now look at this. On a grid like this, you do slope, but you still can. Go 1, 2, 3, 4 over 1, and 1 should line up with this. And so go 4 and right 4, you should get the point right about there. You know, you can, something like this, it's not on the lines. Do your best to estimate it, and I'll be happy, okay? What I'm saying, that's the rectangular equation for that line. All right. Now look at the this worksheet that you picked up today. And by the way, I'll just tell you right now, the test is day after tomorrow, right? I'm not grading these worksheets you're picking up today. Okay? I'll put the key out there. Practice, practice, practice. All right? Look at, actually, 49. We're going to modify this. We're going to not worry about that part. 49 through the next, these 4 problems. So through 52. Get rid of that. And only those. Don't do the back. Go back to 49, and someone tell me, what shape is that? What shape does that represent? Good, a line. Let's go ahead and draw this one. And we're, look, this becomes the same as r equals 10 over sine, right? Times cosecant, same as over sine. Move the sine over, divide my sines on that side, and then multiply my sine on the other side. You get this. And that's y. So yes, that's a line. It's a horizontal line going through 10. By the way, this is not sufficient. You need to somehow scale your axes. And if you mark any point, like if the third point is 6, then fine. You're going by 2's, obviously, and that's sufficient. I'm saying you don't have to label every point, but you have to label at least one of them. Label this one here with 10 if you want to. I don't care. So there, we're done. Now, and we are done. We got both forms. I just want to warn you, when you look at these equations in polar form, look, this is the equation for a line. If I wrote r equals 10 sine of theta, that'd be a circle, right? They look very similar, so be careful. Basically, I wouldn't even leave it in this form. I would, if you have that, go ahead and write it as rectangular, and you know it's a line. It's easy. Be careful. All right, look at number 53. We're going to do this one together because it's a bit much. All right, we're going to factor. The numerator, just factor out of 5. And how do I factor that denominator? Well, 2 binomials, what will they be? Yeah, cosine plus sine is one of them. And minus is the other one. Cosine minus sine. It's just for the record, you have 2 formulas you're supposed to know. If I gave you something in this form, what's that? That factors into a binomial times itself. If I gave you something in this form, difference 2 squares factors into conjugates, a plus b and a minus b. Okay? So that's where those come from. Now what, Zoe? What should we do now, do you think? You get that? Just cancels down. Let's rewrite it. You get r equals 5 over this. Hayden, what do you suggest we do now? You can't, you gotta be careful with this. Watch. And don't worry, someone last period recommended the same thing. The thing is, if it was, cosine times sine right there, then you could rewrite that as like 5 times secant times cosecant, which wouldn't, frankly, get us very far anyway, because I wouldn't know how to draw it necessarily, but we can't do that anyway. Okay? It's a binomial. Any other suggestions? Yeah. And, yeah, we would square it, but that would make the left side nice, but the right side would be kind of ugly. What we're actually going to do is what Kristen recommended. Here, look this way. If you want to, you can think of making it a fraction here and you're cross multiplying. Really, I'm just multiplying this side by that denominator. I'm rewriting as r times that denominator. Dividing on one side of the equation is the same as multiplying on the other side of the equation. And mind you, I'm distributing as I do that. So I'm taking that denominator that was on that side and multiplying it on the other side. Which gives you can anyone tell me what that's the equation for? Let me rewrite it as y equals. What I'll do with y just has a negative coefficient, I like to just move it over. You move this over, you get x minus 5, which is the equation for a line, right? Yes. You used to see it in slope-intercept form. This was standard form for a line, which we don't like so much for graphing purposes. Although actually it's not bad. And here, drawing on this graph is once again can't be a challenge. The y-intercept though is at -5. That's not bad. Your slope is 1, so you have to go up 1, right 1, up 1, right 1. Actually, you just go to here, at that point, right? And go up 5, right 5. So, first if the slope was like 4, like we had before, you'd have to kind of estimate. But here, that works very well. That was kind of weird in terms of, the algebra you had to do, but turns out that's the equation for a line. All right. We're going to do this one now. Now, first of all, we need some formulas. The sine of a sum formula. And write this down somewhere in the margin or something. Remember these? For the cosine formula, it goes cos. Cosine, cosine. Then what? Yeah. And then sine, sine. Now, I do it first for one thing, you need it for the other problem, but also because we memorize that very easily, and then the sine formula is different. It doesn't go sine, sine, it goes sine, cosine. The function switches, and the plus stays a plus, it doesn't do opposite. What goes here? This is on the, this is on the paper you picked up today. And then sine of beta. Because we have cosine of beta here, that must be sine of beta. Okay. And so we're going to take this thing and rewrite it using that first formula, so it becomes 2, and the 2 times the whole thing, mind you. So it's 2 sine of theta, cosine of the second angle, plus, and then cosine of theta, sine of pi over 3. Is that it? Okay, good. What is cosine of pi over 3? So I'm just going to replace that with its value, and over here do the same. And actually, when I then distribute, I'm doing 2 times this whole term, but the half cancels, and then 2 times this whole term, and it loses the denominator too. So my equation becomes just plain sine of theta here. By the way, it was r equals all this. So r equals sine of theta plus square root of 3 times cosine of theta. Not wonderful, but not too bad. Now, I have a formula that says r sine of theta is y, right? So if I were to multiply by r on this side, I'll do both sides, then these will match my formulas. So I'm multiplying both sides by r, because then I have r sine of theta there, and r cosine of theta here. And then we have it. We're trying to get rectangular form. There's a bit of work, but that's x squared plus y squared. And that's y. And that's square root of 3 times x. And then we still have to rearrange that to know how to graph the thing. It is going to be a circle, though, as it turns out. Which, mind you, should have realized this, well, guessed maybe this is going to be a circle. If this was gone, 2 sine theta would have been a circle. It's just not already a normal circle. All right, we're going to rearrange this thing. I'm going to move the x term next to x squared. First, wait, that's a problem. Square root of 3 times x. Leave a space. Then you have the y squared. The y comes over here, goes next to the y. So I just grouped all the x's together, all the y's together, and both these change sign because they moved across the equal sign. And now we get to complete the square, which isn't as bad as it looks like it's going to be. Let's do this one first. To complete the square, here you take half of the 1 that's in front of the y, which is a half. What do you get when you square that? 1 squared is 1, 2 squared is 4, yeah? I'm going to put the 1/4 there because I'm going to put a different number, another number there for it. And then here, do the same thing. Like I said, it's not actually that bad. Half of square root of 3 is square root of 3 over 2. When you square it, what do you get? This squared is 3 over 4. Which you add to both sides. And the right side works out to 1, and we are done. Where's the center of that circle? Positive square root of 3 over 2. 1/2. This is r squared, actually, right? But the square root of 1 is 1, so the radius is 1. This actually is not bad in terms of graphing it. That is a point on the unit circle, so it's at pi over 6, yes? Go to pi over 6, go to the unit circle, which is, right, the radius 1. So that point, the center of the circle is there. The radius is 1, so go out 1 beyond that, 1 back in. There's 2 points in your circle. And frankly, we're not going to try to do the side points. Just try to make it look circular, and you're good. We're done. Now, yes, that was a lot of work. So, after we see this finished product, any idea how you could have known that the circle would be there based on the original equation? Right. First of all, tell me this. If this wasn't there at all, which way would that circle be drawn? Right? Positive sign would be due north, right? Above the pole. So what happened to it? Rotated pi over 3, but backwards, because you do the opposite again. That's it. Now, so you could have done that, really. Just realize it's that, rotated backward pi over 3, you have your circle, done. And so, if it just wants you to graph it, you don't need to go through all that. If it asks for the rectangular form, though, then yeah, it's a bit of work. 55, I'm going to let you do on your own time. It's easier, though. Just for the record, if I want to graph this one, without that, it'd be which way? Due east. If you rotate backwards that much, it'd actually be due south. That's what you're drawing there. It's easy. But do the algebra, okay? Just like 54. 56, I'm going to call it bonus. It's a little weird. I'd say it's definitely a calculator problem. And that's all I'm going to talk about on this. Look at the other sheet you picked up with a 9 and 5. All right. This is technical review. We did this at the beginning of last semester. Of course, I know it was a long, long time ago. But write that down somewhere. And I'm not going to do like a separate note sheet. We'll just do a few problems on the worksheet, kind of examples, and that'll be it for notes. But put that down. Listen, when I say rectangular form and polar form, like I said, that applies to vectors, really. A vector is normally written in polar form, or you think of it as magnitude and go in a certain direction. But you can also write in component form, which is horizontal and vertical. Coordinates can be polar or rectangular. Which one's rectangular? R theta or XY? XY, right? Polar is R theta. Same thing here. That's your magnitude, and that's your theta. It's kind of a weird-looking form, but you should recognize it as polar. And here that's horizontal, that's vertical, just like any other rectangular. Okay? And one more thing you might add somewhere is just that if we graphed it on, I'll put it up here, if we graph it on with rectangular, the horizontal axis is the real axis, and the vertical axis is the imaginary axis. Okay? All right, we're going to do some of these down here first. Number 20, start with that one. We're just plotting a point, okay? And call that z equals. Normally, if you have a complex number, and that's what that represents, it's just a number. It's just a, and seriously, listen to me. This, normal numbers, you can plot them on the number line, right? Well, here you're plotting in the number plane. It's a whole plane of numbers, and it takes two numbers to describe it. Look, just go out pi over 3, go out 4, 1, 2, 3, 4, and there's our point. There's where z is on this number plane. So that's using the polar form they gave us. That's your magnitude, and that's your angle. Now we need to convert that into rectangular form, which is easy. You do the magnitude times cosine of theta for the horizontal, and you do the magnitude times sine of theta for the vertical. Like I said, same formulas. This is 4 times a half, right? 4 times square root of 3 over 2. So 2 for that one, 2 radical 3 for that one. Now it's not a point, it's a number. Rectangular form is a plus bi. Except notice, if you have a radical, we don't normally write this, like that. If you do, I will not take off points, unless you do this. If you write 2 times square root of 3 with I under the radical, then I'll count wrong. It's not the same. So just don't put it there, I'll put it in front, then there's no question. It's just for the record, you don't want to even talk about square root of I. But since I brought it up, I think it's like this. That's the square root of I think. I don't remember exactly, but yeah, it's not pretty. All right, let's go back a step. Let's do this one. Now, that is not 6 degrees, that's 6 radians, which is in which quadrant? Definitely fourth. Isn't 2 pi radians all the way around, that's 6.28 radians? And so we'll get to that. But it'll be on this line, somewhere around here, definitely, is where the point is, okay? Let's go and do the conversion first. You need a calculator, type it in. Make sure your calculator's in radian mode. Because I'm saying all the way around in radians is 2 pi radians, right? But that's 6.28 radians. I mean, right? 2 times pi is 6.28. That's what I'm saying. Look, half a circle is 3.14 radians. And so if you rotate 6.28 radians, actually you have to be exactly 2 pi to be here, but 6.28 is basically all the way around the circle. So 6 radians is close to that. That's all. Yeah. It's not 6 pi. That'd be totally different. I know, and that's what you have to be careful about. We're in radians, but not in exact form, but rather decimal form. And by the way, if we're in the fourth quadrant, you should have positive x, negative y. This is 9.6, wasn't it? And then negative 2.8. Is it around 2.8? Is that right? You can tell I've done this a few times. So for a rectangular form, you write 9.6. The real part goes there, and it's minus 2.8 pi. Now, we're going to scale the axes, obviously. And I highly recommend that you label both axes, otherwise you'll make the mistake I did. I say, oh, 2.8 is like here. No, because this is 2 and this is 4, and this, right? So 2.8 is actually, well, that's 3, so 2.8 is like here. But these graphs, I don't know if they're perfectly circular. The point actually ends up right about there. The reason I know that is, do something for me. Convert 6 radians into degrees. Six radians. I mean, like that. That's how you convert from. Wait, what? No, you get 300 something. Take your radians times 180 degrees per pi radians. That's okay. 300 what? 43.7? Well, if that's true, then our point should be a little more than 15 degrees away from all the way around, yes? Like 16.4, 16.3 degrees. So that's something actually, and this is 15 degrees away, so that's why the point's actually there. Listen, if you've got the point somewhere in this vicinity, I'm going to be okay with it, frankly. With something weird like this, where it's decimals. All right. That's going from polar form into rectangular form. Let's go back the other way. Number 11. And it's another calculator problem. Number 10, you can do without a calculator, but number 11, you'll need a calculator. First of all, we need the magnitude. You find the magnitude exactly the same way you find r. Pythagorean theorem, which is also how you find the magnitude of a vector. 4 to 5, yes? And then how do I find theta? You get same four formulas for all these conversions. You have x equals r cosine theta, y equals r sine theta. Pythagorean theorem and tangent of theta equals y over x. Which one should we choose? And when I say y and x, that's equivalent to a and b. So basically I have a and b, so I should use tangent. And its tangent is b over a, because it's vertical over horizontal, okay? So that's the formula we're going to use. So it's 1, this is a coefficient of 1, right? B is actually that coefficient. So yeah, it's 1 over negative 2, which is a calculator problem because we know where like sine is 1/2 and not where tangent is 1/2. So type in inverse tangent of that, tell me what you get. And frankly, I'm going to do this problem in radians and in degrees. And you should expect a fourth quadrant angle. What is it in, what did you get? 0.46? Yeah. What about degrees? Okay, and put a degree mark there. Now, here's the thing. When you go to write your polar form, you better not use those angles. They're both wrong. Because which quadrant is this point in? Second, right? And so here, first, I need a second quadrant angle. And use that basically is your reference angle. So put 0.46 here. Subtract from pi and tell me what you get. What's pi minus 0.46? 2 point something. Someone tell me what it is. 6.8? Okay. And do the same thing here. The reference angle is 26.6 degrees. You get 100 and what? Okay. So now let's write them. I'll write both versions. If it doesn't specify, I'll accept it either in degree mode or radian mode. Okay. I'll leave it up to you. And look, like I said, once you know the magnitude and theta, you just fill it into this form. And that's your answer. So the magnitude goes here, then it's cosine of your angle, which was 2.68 radians, plus I times sine of your angle. And that's your number expressed in polar form. If you do it in degrees, the same thing. It's just going to use the 153 instead. So plus I times sine of the angle. And there you go. There's the answer expressed both ways.